Hello students, in this video we are going to look at the interval estimation using t-distribution. Let us first understand what is t-distribution. Early theoretical work on t-distribution was done by a man named W.S. Gossett in early 19,000, and where he was employed that place it was not allowed to publish using their own name, or publication was restricted, so he used a pen named called student. And he that is why the t distribution is commonly called as students t distribution or simply students distribution. Typically it is used for small sample sizes, which is less than 30, and it is a bit flatter compared to normal distribution t distribution, and every sample size there will be a different t distribution. So as the sample size approaches 30, the t distribution approaches normal distribution. So at 30 normally we can use both equivalently, but we prefer to use z distribution when it reaches 30. Below 30 we use t distribution. Okay, so let us uh, t distribution when to use and z distribution when to use. This you can, if you can just remember this, whenever the sample size is less than 30 and population standard deviation sigma is not available, not known, then you should use t distribution. If population standard deviation is available, then irrespective of sample size you should use z distribution. So this, to be remembered, when we are using t distribution, in the table we require to use degrees of freedom. So what is degrees of freedom? Degrees of freedom is actually how much free you are to select particular values, or we can say we can define them as the number of values we can choose freely. To understand it properly, let us consider that there are four numbers which we have to find, which will add up to 100. And when you start choosing first number can be anything, second number can be also anything, third number can be also anything, but the fourth number, plus minus, numbers can be plus minus, the fourth number gets automatically fixed once you select three numbers. So that means you are free to select three numbers. So it is, in case of n numbers, it is n minus 1. So degree of freedom is n minus 1. So when we are using a t distribution, there is no other change in the formulas. We are going to just replace z values wherever z value comes with t value, and we will be using t table to find out the t value. Rest everything remains the same. So let us understand the use of t distribution using a example here. In a generating plant, the power generation plant, the plant manager wanted to estimate coal needed for this year, for the entire year, and he took a sample by measuring coal usage for 10 weeks, and from the sample he got sample mean of 11,400 tons. X bar is 11,400 tons. Actually this is per week consumption, and sample standard deviation S is 700 tons. That is what he found, and he wants to estimate for the entire year, which is basically your population. The plant manager wants an interval estimate for the mean coal consumption, and he wants to be 95% confident that the mean consumption will falls within that interval. So basically they have given us confidence level of 95%. Indirectly it means significance level of 5%. So let us look at the solution. Now since the population standard deviation is not available and the sample size is less than 30, so these two conditions clearly tell us from this table here that population standard deviation is not known and sample size is less than 30. So clearly it is an case of using t distribution. Also, because population standard deviation is not available, when we were trying to find out the standard error sigma x bar, we cannot use sigma because sigma is not available, but we use sigma cap, which is s. In this case, the sample standard deviation becomes our best estimator for population standard deviation. So the sigma x bar is s upon square root of sample size, which is 10. So it comes to around 221.38 is our the the error, standard error. Now we have to now use the degrees of freedom because we have n equal to 10, degrees of freedom equal to 9, and confidence level required is 95%. So significance level is 5%. So when we look at the table here, which is this is the t table. So t table, these values are area in both tails combined. Area in both tails combined. So we want 95% confidence means we want the area under this area is 95%. So outside area is 5%. So both tails combined is 5%, which is 0.05. So we are going to use, so here we are going to use but what we want is 5% in both the areas. So in one area it will be 0.025. We want 5% in both the legs, right? So 0.025. So 0.025 we want to find out the z value, but we have to look for here 0.05, right? And from our degree of freedom is 9 and 0.05. So we will get the value as 9 and 0.05, 2.262. This is the t value. So 0.05 and 2.262 is our value. So now our formula is mu because we are trying to estimate the population standard deviation equal to x bar plus or minus t times sigma x bar. We replace z by t. So x bar is 11,400 plus or minus 2.262 into 221.38, and we get the answer. The upper limit is 11,901, the lower limit is 10,899. So what we are concluding here is that with 95% confidence we can say that the yearly consumption average will be between 1089, 899 and 11901. That is our conclusion. Thank you. In my next lecture we will now look at the hypothesis testing.